Next up, we're working on an example that uses our kind of like option A for how we pick G1, G2. And so that example is going to be that we want to solve the differential equation y double prime plus 4y prime minus 2y is equal to 2x squared minus 3x plus 6. And since we're focusing on this new part, the undetermined coefficient method, I'm going to give you the solutions that come from the constant coefficient part. So just know that y double prime plus 4y prime minus 2y equal to 0 has solutions y1 equal to e to the minus 2 plus root 6x, and y2 equal to e to the minus 2 minus root 6x. You know how to find that using the constant coefficient approach, and we need it to write the general solution, which is made of y1, y2, and yp. And then to find that yp, we note that the g of x we're given is 2x squared minus 3x plus 6. So I'm going to look at that and pick out the functions that make up g. And that gives me, like we talked about, g1x squared, g2x, and g3, any constant number. So the guess that I'm going to start this problem off with is that yp is equal to ax squared plus bx plus c, where a, b, and c are my undetermined coefficients. I need to take my assumed solution and plug it into my differential equation. That means I need derivatives. So yp prime is just going to be 2ax plus b. X squared becomes 2x, x becomes 1, and then the constant goes away. And yp double prime, derivative of x is 1, so I get 2a, and my constant b goes away. And then once I plug this into the ODE, I'm going to go to this full version up top, not the version that's equal to 0. And I'm going to have that on one side, I expect to get 2x squared minus 3x plus 6. And then I want this to be equal to my particular solution plugged into the ODE. So that's yp double prime plus 4yp prime minus 2yp. And then for those derivatives that I took, yp double prime is 2a, plus 4 times yp prime is 2ax plus b, and then minus 2yp, which is ax squared plus bx plus c. I'm going to go ahead and simplify this a little bit. I know eventually I'm trying to solve some kind of algebra equation, but this is a little bit difficult to tell what I'm solving for at this point. So I'm going to distribute everything. 2 times 4 is 8ax plus 4b minus 2 times ax squared minus 2 times bx. Remember, when you have a minus here, make sure to distribute it all the way through. These problems can get a little bit long, and making a mistake so early is kind of frustrating. So just be careful. Minus 2c. And then real quick, I'm just going to flip back to the steps. Remember that we wanted to group like terms, and that means the things that are similar to the functions I've introduced. So what I want to do is I want to take all my x squared terms and group them up, all my x terms, group them up, so on and so forth. So x squared is multiplied by minus 2a, and x, it's only that one term, so there's nothing to group with. X, I've got that 2a, no, 2a is by itself. I've got that 8a and that minus 2b. Both of those are multiplied by x, so I go ahead and group them there. And then Actually, I'll go ahead and leave it. I'll just use different symbols, I guess. I'll do that one. That way I can tell which terms I've already used. And then my plain constant terms are these three. The last g I had was g3 equals 1, so I put that 1 right there. And it's multiplied by 2a plus 4b minus 2c. And then on the left side, I want to emphasize how that's also constants times these same functions. So 2x squared is x squared times 2. 3x is plus x times minus 3. And 6 is 1 times 6. I did not give myself enough space to write that, but hopefully you can see it okay on the screen. And now what I'm going to do is I'm going to set groups of coefficients that multiply the same types functions times each other, or sorry, equal to each other. So my x squared terms are going to end up equal to each other, x and constant. So that's going to give me on the next slide a few equations. So hit pause if you're still writing that last line for yourself. But from my x squared terms, I had minus 2a equal to 2. And I'm going to write all three equations, then flip back and kind of point to where it came from. For my x terms, I've got 8a minus 2b is equal to minus 3. And for my constant type terms, I've got 2a plus 4b minus 2c equal to 6. We'll come right back here in a second, but I have that 2a equal 2, 8a minus 2b equal minus 3, and 2a plus 4b minus 2c equals 6. So just on both sides, I put everything equal that multiplies the same functions. This is a system of three equations with three unknowns, a, b, and c. So it's going to be a little bit difficult, but I definitely can find all these values. From minus 2a equal 2, so I've got minus 2a equal 2 tells me that a is just equal to minus 1. So that's a nice, easy equation. And then once I know a, I can go ahead and plug it in down below. So this becomes 8 times minus 1 instead of a. Minus 2b is equal to minus 3. That means that minus 2b is equal to minus 3. This is minus 8, so when I move it over, it becomes plus 8. So that's equal 5. And that means that b is equal to minus 5 over 2. And then now that I know a and b, I can plug it in here to get c. So I've got 2 times minus 1 plus 4 times negative 5 over 2 minus 2c is equal to 6. So that's minus 2 minus 10. Yeah, that's 10. Minus 2c equals 6. Or minus 2c is 18. Because I moved the minuses over, becomes plus 2 plus 10. That means that c is equal to minus 9. So now I know what a, b, and c are, which I needed in order to specify what y sub p is. This was one of those equations where you can start at the top and kind of go down. In this section, sometimes you'll have equations where it's easier to like simplify two together and then go back to the third. Just solve this however it's easiest for you every single time. But no matter what, we know what y sub p is. It was supposed to be ax squared plus bx plus c. And now that I know a, b, and c, I can say that that means minus x squared minus 5 halves x minus 9. And then my general solution is going to be equal to y is c1 times y1 which I gave you earlier on in the problem. But if this was sort of like a fresh problem that you're working on, you might have to have found it. That's negative 2 plus root 6 times x plus c2 times y2. That's negative 2 minus root 6 times x plus our y sub p. And for us, that's that minus x squared minus 5 halves x minus 9. So that's plus yp. That's c1 y1 plus c2 y2. General solutions are given by that. Let's see. Okay, so now that that example's over, we're going to move on to the more complicated examples in the next videos.